Bismillahirrahmanirrahim. Welcome to the third part of this lecture, which is speaking about the volumes. As we stated before, that the volume is given by the integration of the cross-sectional area AX dx over a given interval A to B. In this example, we are going to find the volume of the solid obtained by rotating the region R enclosed between these curves. I have y equal to e to power x, and we have y equal to 0, x equal to -1, and x equal to 1, and we need to rotate it about the x-axis. So sketching the region for this one, I have y equal to e to power x, it is exponential function. Take this shape. This is y equal e to power x. And y equal to 0, it is the x-axis. This is y equal to 0. And also we have x equal to 1 and -1. So this is -1 and x equal to 1. Or make it close to 1. This is equal to 1. So I need to find the volume obtained of the solid obtained by rotating this area. This is my R. So to do it, as we did before, graph typical rectangle and rotate it about the x-axis. I will have disk there, like this one. So the shape will be like this one, or more accurate, I will have something like this. This is for the whole graph. If we are just thinking about -1 and 1, you have to cut this part, and the graph will be like this. Just cut it because this goes for the minus infinity to plus infinity. I need just a small part of this one. And this will give me the cross-sectional area. R is given by the height of the function. As we stated before, this is the R. Good one. This is R. It is the height of my typical rectangle. Or it is y1 minus y2. R is given by y1, the upper one minus the lower one. That is e to power x minus 0, which is equal to e to power x. So ax, which is given by pi r squared, that equal to pi times e to power x all to power 2. Or it can be written as pi e to power 2x. Now to find the volume for this solid, we are just integrating the cross-sectional area. Integrating the cross-sectional area over the given interval -1 to 1. So the volume is given the -1 to 1 of ax dx, which is equal to -1 to 1 by e to power 2x dx. This is equal to y over 2 e to power 2x, -1 and 1. Using the fundamental theorem of calculus, this will give me y over 2 multiplied by e to power 2 minus e to power -2. So this is the volume for this solid. And we can write the unit as a cubed unit. Another example. So with that, I need to find the volume of the solid by rotating the given or enclosed R. R is given by or enclosed by this curve x equal to 2 square root of y, x equal to 0, y equal to 9. The first function x equal to 2y or square root of y is given like this one, which is this curve now. Y equal to 9. So I will have this region x equal to or between x equal to 0 and y equal to or. This one. It's clear. Now, and we need to rotate about the y-axis. I will have this shape, because if we take the typical rectangle and rotate it about the y-axis, I will have a disk. Like this one. Take this shape. About the y-axis, I will have a cross-sectional area which is circle. Now, to find a of y, not a of x, because this is horizontal, or it is about the y-axis, this is my r. R is given by x1 minus x2. If we rotate about the y-axis, we are saying x1 minus x2, or the right curve minus the left curve. This is equal to 2 square root of y minus 0, which is equal to 2 square root of y. So r in this case is equal to 2 square root of y. Again, it is the left, so the right minus left. Right minus left. So this is r. A of y is equal to by r square, which is equal to by multiplied by 2 square root of y square. This will give me 4 by y. Integrating cross-sectional area, volume is equal to, it's given from 0 to 9 in the problem. But this is 9, the upper limit, and start from the origin. X equal to 0, that will give me y equal to 0. So the limit between will be between from 0 to 9 of a y dy, which is equal to 0 to 9 of 4y y. dy, which is equal to 2 by y square. Integrating y, I will have y square over 2. Or we can make it 2 steps. This is equal to 4 over 2y square. Between 0 to 9, that will be 2y multiplied by 81. 81 minus 0, which is equal to 162 by. So the volume for this solid will be 162 by cubed unit. This is the idea of finding volume of a solid by rotating a given region R about y-axis or x-axis. All what we need to find the cross-sectional area A of x or A of y, and then we integrate it over the given interval A to B for x or C to D for y, and that will be the volume of the given solid.